In data science, when we build a statistical model, there are three different kinds of models we might be building. The first is a regression problem. We ask the question, how much? And what we're trying to predict is a number. Then we also have classification problems, where we ask which one. And what we're trying to predict is which out of a fixed set of possibilities is the outcome most likely to be. Finally, we have forecasting problems as well, where we're trying to actually make predictions for many time periods. And in essence, what we're going to do is take a single evolving process and understand how that process will look over time. Let's take a look at a couple examples of each of these types of problems. We can see that regression here might include questions like, what price do I expect to get for this house? With the variables being the size of the house, the square footage, whether it has a yard, number of bedrooms, the zip code, etc. What is the lifetime profitability of my customer? How many goals or runs a player might score in a season based on sports analytics? Or what are the drivers of customer satisfaction? My score of 1 through 10 on the survey, what drives those higher or lower scores? Classification might ask questions like, who is churning? This might be customer churn, employee churn, membership churn, etc. Which machines are at risk of breaking down, whether they break down, yes, no, and the causes being the temperature, the pressure, etc. Which team should I route a support ticket to? We can use natural language to parse the ticket contents and then decide what team we should automatically send the problem to. And questions like, what species of bird is in this picture? And finally, we have forecasting problems, which asks questions like, how many inventory units will I have for each of my SKUs over time? How many flu cases will there be over time? What can I expect from my store sales each week for the next year? Or how much usage will there be on my database? Is it growing? Is it shrinking? Do I need to invest in new hardware? Let's just quickly take a look at how this works. So we'll start with the regression problem. Here we have a data set that represents the score from a customer satisfaction survey that we have, the customer's overall satisfaction level, and some information about what business unit, industry, and how we contacted them, among other fields. We would want to train a model to understand what drives higher or lower customer satisfaction. And because we know score is a numeric variable, we include this as a regression task. For the input features, we are using survey type, country, business unit, industry, and as well as how we contacted the customer. We have a set of metrics that we'll discuss in a different following video, but we're doing a regression task. And what we're going to do is train a model to minimize the error, which is the difference between the predicted and actual customer satisfaction, and understand what are the factors that drove this prediction so we understand what drives customer satisfaction. Here, when we look at the explainer, we can see that we have a set of customers who are responding to us, and their country of origin is the biggest contributor. When we look at a single prediction, we can see that this customer was predicted to have a 7.3 customer satisfaction rating. And we see that, being part of the business unit gateway, being contacted through telephone, being a particular company, a particular survey type, and a particular industry made them less happy. But being from our Japan business unit probably made them a little bit more happy. Next, we can take a look at an example where we're trying to predict churn. Our key variable is whether they cancel a membership or not. And we have some demographic attributes as well as some characteristics of the store and customer relationships. Here, what we can do is to create a prediction of whether they churn or not, targeting that cancellation membership variable, selecting all the features that we care about, identifying correctly that's a classification task, And again, we'll talk about these metrics in more detail in a subsequent video about selecting the correct metric to optimize for in this classification task. And then running this model. And what we're going to get back is the explanatory factors of whether or not the customer churns or not. As time passes and we search for better and better models, the accuracy increases. And in this situation, we not only get the ability to say whether we predict a churn or not, we also get back a probability of churn, and we can actually identify the customers with the highest likelihood of churn and seeing the factors that go into that using the explainer again. We see here that having a store credit card makes you much less likely to churn, and we can take a look at some examples of why someone was not expected to churn. So here we say likelihood to be true. We see that, they have some mitigating factors such as being a 38-year-old divorced individual with 9 years as a customer. Even though they don't have a store credit card, they actually have some other positive factors about them. Finally, we might want to forecast some data. So here we have the number of flu cases over time. We can visualize this as a total number of flu patients over time, and we can see that there's this pattern and there's some seasonality here going up in the winter and down again in the summer. We can use this forecast operator where we care about the time. Let's say, the average per month of flu patients, and understand for the next few years how many flu patients we can expect to see. And maybe I would want to train it so that the training period goes until 2013, and the actual test of the accuracy of the model is from 2013 to 2018, and we can extend the horizon of prediction past 2022. And here we can see the red line is the predicted trend of number of flu cases. And here we see that we've gotten to 3 different kinds of prediction problems. The first is a regression problem where we were trying to predict a numeric variable of satisfaction. The second was a binary classification of cancellation. And then the third was a problem of trying to predict the number of flu patients over time